Hello everyone, this is Longjam Valentina. So in my previous video, I was discussing about Slet 2022 question paper for Computer Science paper 2. 8. It is from operating system. It is a simple question. Here we have to find out the average waiting time for using the FCFS and shortest job first algorithm or CPU scheduling algorithm. So here 5 process is already given. In this question 5 process P1, P2, P3, P4, P5 and its burst time is already given. There is no arrival time, so we have to assume that arrival time is 0. Okay, here let me apply first come first serve. So for this we have to draw a Gantt chart by using FCFS algorithm. First process arrived is P1. Okay, P1 P1 arrived at 0 and its burst time is 8, so it will 8. Okay, now P1 has completed. Then next P2 will serve. Then burst time for P2 is 10, so 10 plus 8 is 18. Then P3 burst time is 4, 18 plus 4 is 22. Next P4 burst time for P4 is 3, 22 plus 3 is 25, and P5 burst time is 20, so it is 25 plus 20 is 45. Okay, so now we have completed. So we have to assume, as I've already told you, that all the process arrived at 0, as there was no arrival time was not given. So we have to assume the arrival time of every process will be 0. Okay, so first, what is the waiting time? Waiting time for P1. Waiting time for P1 will be 0. Why? Because it arrived at 0 and starts serving from 0 itself. Okay, that's why there will be no waiting time for P1. What about P2? P2 arrived at 0. Okay, P2 arrived at 0 and it starts serving at 8. So 0 minus 8 will be 8. P3 P3 starts serving at 18. P4 at 22. P5 at the average. So 0 plus 8 plus 18 plus 22 plus 25 divided by, so we have how many processes are there? It is 5 processes, so it will be divided by 5 and the answer will be 14.6. SJF, shortest job first. SJF, shortest job first. Okay, so again let's draw the Gantt chart. Okay, now shortest job, we have to start serving from the shortest job. Okay, that is shortest burst time. So the shortest burst time among the 5 process is P4. Okay, so P will start serving from P4. 0 and its burst time is 3, so 0 plus 3 is 3. Then next next shortest job is P3 and its burst time is 4, so 3 plus 4, that is 7. Next is P1. 7 plus 8 is 15. Then next is P2. 10 plus 5 10 plus 15, that is 25. Then next shortest job is P5. The last one is P5, so it will be 45. Okay, now average waiting time, waiting time for every process is P1. For P1 it is 7, P2 it is 15, P3 it is 3, then P4 15, P4 0, P5 is 25. Okay, now average waiting time is P1 plus P1 is, that is 7. 7 plus 15 plus 3 plus 0 plus 25 divided by 5. Okay, so after solving this, the answer will be 10. So moving to question number 42, this question is also from CPU scheduling algorithm of operating system. Here let us see the question. What the question says: consider the following 4 process with the length of CPU burst time given in milliseconds. We have 4 process is already given, its arrival time and burst time is given. Then which algorithm we have to use? Here we have to use shortest remaining time first scheduling algorithm. Okay, here we have to apply shortest remaining time first. Okay, this is just like your SJFS, shortest job first algorithm, but here we have to apply preemptive SJFS. Okay, the difference between these two algorithms, this algorithm that is SJFS and preemptive SJFS, is that in this algorithm we'll compare the burst time, we'll compare the shorter burst, we'll compare the burst time of each process only once. Okay, only once, that is at the beginning of the process. Okay, at the beginning of the execution, and keep on executing by choosing the smaller burst time. While in this preemptive SJFS, we'll keep on comparing whenever a new process is arrived, into the CPU. Okay, so let us see the algorithm. So here process, we have 4 process: arrival time and burst time. Let us draw Gantt chart. Okay, at time 0, which process arrived? At time 0 we have arrived only process P1. Okay, only process P1, so I have started executing P1 executed, and when the process arrived at 1, a new process arrived, that is P2. So till now I have executed only 1 millisecond burst time, so remaining burst time is 7. Now we have to compare this 7 with 4. So which one is the smaller? P2. So I will preempt P1 with P2. Now P2 has started at 2 milliseconds. Now P3 arrived. Okay, here we need to compare with P2 and P3. Now till now 1 portion executed, it is 3. So we'll compare 3 with 9, and 3 is still the smallest one, smaller one, so there will be no preemption. Okay, then at P4. Now at 3, P4 arrived. Again we'll compare 2 with 5. So this one is still the smaller one, so there will be no preemption. That's why I need to execute whole burst time of P2. Okay, it is 5. The remaining one is 3 plus 2, that is 5. Now I have completed P2. What is remaining? P1, P3 and P4. So among these three processes, which one is the smaller burst time? P4. So I will execute P4. Burst time is 5, so it is 10. Now P4 also completed. Then P1. P1 is 7, so 10 plus 7, 17. Next, P3. P3, what is the burst time? P3, 9. 17 plus 9 is 26. Okay. So let us calculate the wait time of every process. First process, that is P1, wait time. At first there is no waiting, so it is 0. And after that it was waiting from 1 till 10. Okay, so 10 minus 1, that is 9. That means there is no execution between 1 and 10. So P was waiting at that particular time, that is 1 to 10. So 1 minus 10, that is 9. 9 will be the waiting time for P1. Then P2. What is the waiting time for P2? There is no wait for P2 as it arrived at 1 and started execution at 1 itself. So there is no waiting time for P2. Then P3. Waiting time for P3 is it arrived at 2 and started execution at 17. So 17 minus 2, that is 15. Then P4. P4 arrival time is 3 and execution started at 5. So 3 minus 5, that is 2. So average wait time is 9 plus 0 plus 15 plus 2. That is average wait time. So we have 4 processes, and now after calculating the answer will be 6.5.